Okay, so yeah, so thank you for inviting me to talk, and it's great to be in this session um, with my other colleagues. We don't get enough chance to talk about what we're doing with our teaching. So, like the other speakers, I'm in the Department of Physics and Astronomy at UCI. I was much less ambitious than and successful than Laura, I'd say. I included elements of specs grading in 2 courses since learning about specs grading during the workshop last summer. So the first was in the fall. It's an Introduction to Cosmology. That's the upper division, what we call a capstone seminar for physics majors. There are about 40 students, and that was taught in person last fall. And also in the winter, I tried some different things in a class. It's called Electronics for Scientists. It's a lab class, although not really a traditional lab. It had an enrollment of about 25, and it's a bit unusual because it's a class taken both by undergraduates and graduate students. So it's cross-listed. And then also we taught that, as Michael mentioned, we taught that remote for the first few weeks and then in person during the last few weeks. And for both of these courses, I had no TA or grader support, so that definitely guided the things that I tried to implement. So in the fall, Introduction to Cosmology. So the main thing I focused on was developing learning outcomes following the guide that we learned about at the workshop. I put a link to it here. And so I didn't have these written down at all before. And in reading and how we're supposed to approach this, I did it at quite a granular level. So so the outcomes, there's a page of outcomes for each module, which represents about 1 or 2 weeks of material in the course. And I was able to get all of these laid out and available for the students before the quarter started. So they really had a fairly detailed roadmap. So this is the Canvas page. So I'm using the Canvas module system. So here are the modules. And if we drill down just to that first module here, so we see the different items in the module. And so what I'm talking about is what I call them actually skills in Canvas. So every module or chapter, I have a document on Canvas laying out the skills that I expect them to acquire. And then there's a quiz, which is closely tied. So it's very clear how the skills, the learning outcomes are tied to the evaluation. If we actually look at those chapter 3 skills, so these are the skills I expect you to develop from our study of chapter 3. So one of the things I learned, and I wouldn't have done this otherwise, is that it's important to write these learning outcomes in a very kind of direct, active way. So you don't say understand the equivalence principle. It's really something you want it to be very easy for the student to know whether they've mastered this or not. So understand is very vague, but state the equivalence principle. You clearly have to be able to just write it down and describe how it might be tested with measurements. So making it very concrete. Give examples of inertial and non-inertial frames. So that's the level, and you can see there's 8 here. That's typical, roughly around 10 for each module, which is then 1 to 2 weeks worth of material in the course. And then this is directly linked to the grading. So then we have a quiz, and so here's, for example, the quiz that goes with this chapter. And the quizzes they're actually open book. And the first question ties directly to this learning outcome I underlined in red. State the equivalence principle and describe how you could measure an object's inertial mass. So it's just a minor variation on exactly what was stated in the skill. So the students learned over the course of the quarter that that these learning outcomes really, if they read them carefully, they could tell whether they had mastered them before the quiz, and really knew whether they were prepared and making progress as I had defined it. So. Okay, so turning to the other class, Electronics for Scientists. So this is a lab class. I mean, we do it in MSTB. traditionally, but even before the workshop, I transformed this class, during the start of COVID, from a traditional lab class into something more flexible and also more modern. So instead of using equipment that was present in the lab on the workbench, each student had a kit, just in a little bucket that they would pick up at the beginning of the quarter for my home actually, and then take home and just use at home to do all of the project work in the class. So we would meet during the lab time, but students would, everyone would be building and operating their circuits from wherever they were. There's just some photos kind of showing you the contents of the kit. And then the grading here is mostly based on project work, where the projects are defined, but the students are working, doing most of the work independently, so not in a group setting. And so the main aspect of specifications grading that I think implemented successfully here was to develop specifications rubrics for each project. So these are the links I found helpful. So Renee, in her presentation, this actually jumps you to the right moment in her presentation where she talks about kind of her before and after transformation of rubrics. And also, implementing this in Canvas was new to me. So the Canvas documentation is useful too. So just taking an example for one of the projects. So for every project, generically what the students turned in was the same. They would turn in a video. They would usually just take on their phone, kind of just showing what they had done, showing their circuit, and narrating what steps they'd taken in the project. So I was able to come up with a set of generic criteria which were common to all projects. So like video quality, narration quality, circuit construction. The other main thing they submitted was the code that they wrote. So each, this kind of modern electronics, where a lot of it is in firmware, so they're writing code. So there's some generic specifications on those. And then also for each project, I would have some custom criteria for that specific project. So in this one here, voltage measurement, resistance measurement, temperature measurement. Okay, so then, and this is efficient because you can kind of write you can see about more than half of the criteria are generic, and the students very quickly learn as they get feedback from each project exactly what I'm expecting. So we kind of get consistency in what in their work, and also good understanding of the expectations. And then we just have these a smaller set of specific criteria for each project. So I found that worked well, and I'm kind of using the specifications approach of just the outcome. There's not points associated with here. It's just satisfactory or needs revision. Okay, so that's kind of the highlights of what I was doing in those two courses based on what I learned at the workshop. I want to just thank all of the workshop organizers. There were a lot of people involved, and they put a lot of effort into it. But also, I really got a lot out of during the summer, just talking to the other participants and kind of sharing battle stories of how we were doing things. But also, especially thanks to Steve May and Bo Choi for our one-on-one meetings and kind of answering my questions during the quarter when I was actually implementing these things. Well, thank you.